All right, in the last lesson, we looked at looking for solutions for these linear inequalities in two variables. But now what we're going to go ahead and do is we're going to go ahead and we're going to graph these linear inequalities into variables. And if we take a look at this linear inequality, it looks very similar to 2x plus 3y is equal to 6, right? Linear equations. And so what we want to go ahead and do is we want to go ahead and graph this on this plane here. And in order to do that, I'm not going to do anything besides find the x and the y intercepts. Okay, so the first thing I'm going to do is I'm going to find the x-intercept. And that is when y is equal to 0. Okay, and I'm going to go ahead and separate my work. I'm just going to split it up. Now I know in your notebooks, the bottom half has place like to write and stuff. You can use that part to do this and use this top part for your graphs. Okay, so what I'm going to go ahead and do is I'm going to go ahead and let y equal 0 because the x-intercept is the value of x when y equals 0. So let's go ahead and I'm going to solve this here. All right, so 2x plus 3y, and I want to know when that equals 6. Okay, and that's how I'm going to find my x-intercept. But I'm letting y equal 0, so wherever my variable belongs, I'm going to put a parentheses. I'm going to let that equal 0, and I'm going to solve for x. Okay, this becomes 0, which leaves me with 2x plus 0 is equal to 6. Okay, and 2x is equal to 6. And once I have this here, I'm going to go ahead and divide both sides by 2, and I get that x is equal to 3. So my x-intercept is going to be 3, comma 0. That's my x-intercept. So I'm going to go ahead and plot that right there. Okay, now I'm going to find my y-intercept. Okay, that is the value of y when x equals 0. Okay, so in a similar manner, I'm going to go ahead and solve for x. Excuse me, solve for y. So I'm going to let x equal 0. Okay, so let's go ahead and it's going to be 2 times 0 plus 3y is equal to 6. Okay, now what I'm going to go ahead and do is I'm going to continue solving for this. This is 3y is equal to 6. 3y is equal to 6 is my equation. I solve for y and I divide both sides by 3. These cancel. Y is equal to 2. So my y-intercept is 0, comma 2. So that one's right there. And what I'm going to go ahead and do is I'm going to go ahead and grab my straight edge, which is this post-it notepad. And I'm going to just connect those points there. All right, it looks something like this. Now, I've graphed this linear inequality, but what I'm going to go ahead and do is I want to find all the possible solutions to this inequality. I'm looking for all possible values of x and y to make this possible. And I'm going to pick any point, any random point. In this case here, what I'm going to do is I'm going to go ahead and choose this point right there. Okay, that point. And that point right there is what I'm going to call my test point. My test point is going to be 0, comma 0. And I'm going to take my inequality right up here, 2x plus 3y less than or equal to 6. And I'm substituting in these values in for x and y. Okay, so I'm going to go ahead and do that. So that's going to be 2 times 0 plus 3 times 0. And I have to check to see if that's going to be less than or equal to 6. This is 0 plus 0. And we know that this statement is true. 0 less than or equal to 6 is in fact a true statement. So what I'm going to go ahead and do is I'm going to go ahead and shade everything below my line, right? I'm going to shade everything below my line. If I were to pick a point anywhere on this side of my line, it will be a true statement. Okay, so now that we've done that there, we've graphed this linear inequality. Let's go ahead and let's take a look at this one here. This one looks very similar to the following equation. Y is equal to 4x plus 3. Okay, 4x plus 3. Now, this here it looks very similar to slope-intercept form, right? It looks very similar to slope-intercept form, and we're going to approach it using that same technique, the same way that we would graph this linear equation. Okay, so in this case here, my my slope is equal to 4, or 4 over 1, right? And my y-intercept is 0, 3. 0, 3. So I'm going to go ahead and plot that. 0, 3 is right there. Now I can find my next point by using my slope. That's the change in y over the change in x. Okay, so the change in y is up 4 units and over 1. And since it's a positive slope, right, it from left to right, as x gets bigger, the values of y get bigger. Okay, so now what I'm going to go ahead and do is I'm going to go ahead and plot these points and draw a line through them, right, to connect them. Notice that I'm using a straight edge. So you should be able to use a straight edge as well. You can use the side of your notebook. You can use side of your books. Up to you what you want to use for that. Okay. Now, what I need to do is I need to find the test point. Okay. In this case here, I'm going to choose, again, 0, 0. Since it doesn't go through my line, I didn't choose any of these points here, right? I didn't choose any of these points here. I'm choosing a point that is not on my line, and that's on either side of the line, right? I chose this point, um, and you'll see that I could choose any other point that I want to in just a bit, right? Um, so my test point is 0, 0. Test point is 0, 0. Okay, now that I have chosen my test point, I'm going to substitute it into my equation here. 0 is greater than or equal to 4 times 0 plus 3. And 0 is greater than or equal to, this is 0 plus 3. And this right here is saying, this statement is saying that 0 greater than or equal to 3, or 0 is greater than or equal to 3. And this is not a true statement. Not a true statement. So we shade in the other side. Since it's a false statement, we shade in everything on the other side of my line. Okay, now let's say, for example, I wanted to choose negative 1, 2 as my test point. Let me change the colors so it's a little bit more visible. Let's say I wanted to choose that point right there, which is negative 1, 2, test point, negative 1, 2, into this equation, or excuse me, inequality here. So 2 is greater than or equal to 4 times negative 1 plus 3. I'm going to go ahead and continue simplifying. 2 is greater than or equal to negative 4 plus 3. 2 is in fact greater than or equal to negative 1. All I did was simplify it, right? And this is a true statement, so we would shade in everything on the top side of my equation, my graph, of my inequality. All right, we're gonna go ahead and graph this inequality. Now notice this one here doesn't have a bar to indicate that it's going to be equal to. It's x minus 5y is less than 5. When we have a situation like this, we're going to, similar to when we were graphing inequalities on a number line, and we'd use open and close points. In this case here, this would be similar to when we would have open points, right? This would be similar to when we would have open points. So since this is in standard form, what I'm going to go ahead and do is I'm going to find the intercepts, and I'm going to graph it this way. So x-intercept, I'm going to let y equal 0. Okay, so it's going to be x minus 5 times 0 less than or is equal to 5. I'm just solving for x right now. X minus 0 is equal to 5. So in this case here, x equals 5. So my x-intercept is 5 comma 0. I'm going to plot that right there. 1, 2, 3, 4, 5. That's my x-intercept. Okay, now I'm going to find my y-intercept, and I'm going to intercept, and I'm going to let x equal 0. Okay, so it's going to be 0 minus 5y is equal to 5. Okay, which leaves me with negative 5y is equal to 5. Divide both sides by negative 5 by negative 5. These cancel here, leaving me with y equals negative 1. So my y-intercept is going to be negative 0, comma, negative 1. I mixed those up a bit. 0, negative 1, right there. Bam. Now what I'm going to go ahead and do is I'm going to go ahead and connect the 2 points. So let's go ahead and let's do that. So there we go. And I messed up. Now I did mention that it was supposed to be less than 5. So let me go ahead and correct this really fast. And the way I'm going to go ahead and do that is I'm going to go ahead and graph it again. Okay, now I'm going to go ahead and graph my set of axes here. Okay, scratch that. That was a mistake, and that's fine. Sometimes we make mistakes, and as long as we catch them, right? As long as we catch them. So my x and my y intercepts are correct. So I'm going to plot those again. So 5, 0 right here, and 0, negative 1. Okay, since it is a um, x minus 5y is less than 5, I need to use a dashed line for when I'm connecting these here. Okay, so let's go ahead, let's do that. So I'm going to use a dashed line, still using my straight edge, so my lines are straight. Okay, and it goes through these points here, right? Now I need to find a test point. I need to find a test point. In this case here, I'm going to use 0, 0 since it's not on my inequality. Okay, so my test point 0, 0. Okay, so let's go ahead, let's test it. 0 minus 5 times 0 is less than 5. It looks like it's going to be a true statement. 0 is in fact less than 5. So we shade in everything on this side right here. Okay, we shade in everything over here. Shade in everything above the line, and we make sure that it's a dashed line. Okay. Okay, let's take a look at this last one here. All right, this one here is in slope-intercept form. Notice since I don't have a plus or minus something over here, it's going to, my y-intercept is also going to be my x-intercept at 0, 0 at my origin, right? And similar as if I were to graph this, this would be up 3 units and over 4. My slope is positive. Okay, so it's going to be up 3 units, 1, 2, 3, over 4, 1, 2, 3, 4, right there. I can go down 3 and over 4 as well. Doesn't matter which direction. Now, actually, it does matter which direction. My slope is positive. Now, I'm going to go ahead and connect these points, but I'm going to use dashed lines, all right, because it cannot equal any point on this line. It has to be less than, right? Now, my test point is going to be a little tricky. It's up to you which test point you use. Now, you can choose this point right here. I'm going to choose that point, and let's also choose this point right over here. I'm going to choose 1, 0 as my test point, and negative 4, 0 as my test point, okay? I'm going to check both of them. Okay, so for negative 4 is 0. I'm checking to see which one. Doesn't matter which one you choose, right? You could have chosen this one. You could choose this one. You could choose that point. You can choose this point right here, this point right over here, this point. It's up to you which one you want to use, okay? So this is the first one I'm going to use. So y is 0, right? That's my y. I'm going to substitute it in there. And that has to be less than or equal to 3/4 times -4. If I were to put this into my calculator, 3/4 times -4, this will be -3. Now, 0 is not less than -3. So, this right here is not my solution. All of these points over here are my solution, right? Everything below my line is a solution. Now I'm going to go ahead and I mentioned I was going to try 1, 0. Okay, so 1, comma 0. That means that y is 0, and that has to be less than 3/4 times 1. And 0 is in fact less than 3/4. Let me rewrite that again. 0 is less than 3/4, and that is true. So since I chose that point right there, that's going to be a true statement for this inequality.